Okay, so the first step I did was I looked at the two reactants and put them into my reaction, and that created potassium oxide from the potassium and oxygen, and then I had to balance that equation because that's the first step. And then second step is create the BCA table, and that's what I did by over here. And after that, you put the 0 where the product is, because you don't have your product yet at the beginning of your reaction. Second, what I did was it gave me 4.28 grams, and I had to make that into moles because you can only have moles in your BCA table. Grams doesn't work. And so once I did that, that equaled out to about 0.184 moles, or 0.118 moles. Yeah, that's what's under the oxygen. That's what's under the oxygen, because you took 4.28 grams of oxygen, and that's over here. And then I put that into my BCA table, and I ran that through, and over here, this is a 4-to-1 ratio. So if I had 0.118, I had to multiply that by 4 because of the ratio. And so that equaled out to 0.472 moles. So you take that away because you ran the reaction through, and that leaves 0 on both sides. And how I got 0.236 moles is I multiplied the moles of oxygen by 2, because that's a 1-to-2 ratio. And that equaled out to 0.236 moles. And they asked if 17.36 grams of K2O was formed, what the percent yield was. And that equaled out to be, I did that over here by, and how I got 94 grams was I looked at the periodic table, and I looked at how much grams potassium was, multiplied that by 2, and looked at how many grams oxygen was and added them. That's 94. And I ran that through and got 0.184 moles. And to get the percent yield, the equation is your actual yield over your theoretical yield times 100. And so that's what I did here. My actual yield was 0.184 moles, and the theoretical yield was 0.236 moles. That's what I got in the BCA table. I did that times 100, and that equaled out to 77.9%.